Welcome to Chapter 1 of Statistics. Now, before we start calculating anything just yet, we first have to deal with a more basic question, and that is, where did the data come from? That may not sound very mathematical at the moment, but it is one of the most important questions we will ask all semester. So, because even if we use formulas correctly, our conclusions can still be wrong if the data were collected poorly. So as you walk through this chapter, keep one big idea in mind. Good statistics starts with good data. This video is just a brief overview of the chapter. I'm not going to really walk through every single definition or sampling method here. I'm going to leave that for you to explore through the interactive homework assignments. Instead, I want you to see some main ideas that connect the whole chapter. Before we analyze data or make conclusions from it, we need to understand how those data were collected. If the data collection process is weak, the statistical analysis that comes later can be weak too. So here's the big picture of what we're doing in statistics. Usually we want to learn something about a larger population. That's where we start. Since we can't study everyone in the population though, we often select a sample, a subset of that population. In that sample, we collect data from the individuals or objects within the sample, analyze those data, and then eventually draw conclusions. And ultimately, what we would like to do is take that conclusion and say something meaningful about the larger population. That's this arrow that you see coming back and what it represents. But notice where the process starts. Before we ever get to the calculations and conclusions, we have to make good decisions about who or what we study and how the study is designed. That front end of the process is really the focus here in Chapter 1. If we get that part wrong, the statistics we do later can't magically fix it. So the big idea here is that good conclusions depend on how the study begins. Sometimes researchers simply want to observe what's already happening, and that would be an observational study. Other times, researchers deliberately apply some type of treatment or condition, and then they measure what happens. That would be a designed experiment. The distinction matters because it affects the kinds of conclusions that we can reasonably make. Seeing two things occur together does not necessarily mean that one caused the other. Later in statistics, you will see this issue again and again, that association is not causation. Observational studies can show us an association, but they generally cannot establish any type of cause and effect, where a well-designed experiment can give us much stronger evidence of causation. Chapter 1 introduces several ways that researchers can select a sample. Some of those ways that you'll also see in more depth in the interactive homework assignments are simple random samples, stratified samples, systematic samples, and cluster samples. Again, you'll see in the interactive homework assignments how each one works and when each method might be appropriate. For this video, at the big picture level, they're all trying to solve the same problem. How can we select people or observations in a way that gives us useful information about the larger population? One idea you'll see over and over again is randomness. Randomness helps reduce human choice in who gets selected. And think about why that might matter. Why would we want to reduce human choice? Because people tend to choose what's easiest, most convenient, most familiar, or most noticeable, even when they're not trying to. Using randomness does not guarantee a perfect sample, but it helps keep the researcher from handpicking who gets included. That gives us a better chance of getting a sample that represents the population that we actually want to learn about. Another major idea in this chapter is bias. Bias happens when the way data are collected systematically favors certain results or certain groups. That can happen because of who is selected, who responds, how a question is worded, or how the study is designed. And this is important. Simply collecting more data does not fix bias. If the process is biased, the more data collected in the same way just gives more biased data. So as you work through this chapter, keep asking yourself, could something about the way these data are collected distort the result? So this is chapter 1 in a brief overview. You're going to learn a lot of terminology and specific methods in the interactive homework assignments, but do not lose sight of the larger question. Can I trust how we got these data enough to trust the conclusion? That question will follow us through the entire course and beyond.